Industry 4 and the Australian experience. So particularly looking at what's happening this side of the planet. So certainly if you have a look at Industry 4 on the web, you're going to find a lot of information about you're going to see a lot of images anyway, certainly about robotics, about automation, and about a factory of the future, smart factories and terms like that. The Australian experience is quite different to this. Certainly, a lot of the manufacturing that you do see in Asia and in Europe and in the United States, from our perspective, a lot of that has gone offshore. There is absolutely manufacturing in Australia, but it's certainly not of the vast scales that it is in other places in the world. Our industries are quite different here. And as a consequence, that flavors our Industry 4 experience. So if you concentrate on the factory of the future as your discussion point with Industry 4, you're going to potentially miss a lot of opportunities, certainly in Australia. The difference with the Australian industries are that they are very mobile. We do, of course, have industrial applications, but mobile is very different. One of the things that defines an industrial process is that it's repeatable. That's what gives you repeatable products and good quality. So when you have a machine cycle is usually going to be the same. And it's easy to track, it's easy to log, and it's quite predictable. And that's what you really want. That's a desirable state, is predictability. So the mobile equipment is very different because it's not as repeatable, and it does change. It changes in severity of operation. It changes in environment that it's working in. It's very, very different, and it's not at all repeatable. So certainly from a predictive maintenance perspective, it's more difficult to analyze the data there. It can be done, but you really have to work more at the analytics side of it. So the Australian experience is pretty much that we have mobile equipment, and here's certainly an example of how Industry 4 can be applied. So this is a haul truck from a mine, of course. So these have been, certainly part of our industrial landscape here for many years, and they will be obviously for a long time. You may or may not be aware that these haul trucks are being automated in many sites in Australia. So with automation, basically they are completely autonomous. They're essentially robots. So these robots are very different to the ones in the factory of the future. So, if you think a self-driving car is pretty awesome technology, this is that on steroids, basically. This is everything that modern technology can bring to bear. Now, the reason they're doing this and the reason they're automating these things is because there's quite a few distinct advantages in doing that. One of them is that the rate of incidents and accidents that are occurring are much reduced if you take away driver error and driver fatigue. So basically, a computer that's as a watchdog driving these things, it's self-aware of where it is, sometimes even more than a person can be. So there's been incidents where these can have vehicle-to-vehicle interactions, and there's incidents where these can have, vehicle to, just driving into walls of the mines and the berms and so on. So the robots are a lot more aware of their environment, they're aware of their location, and they do not respond in an unpredictable way. So they're actually more predictable than people. So that's seen as an increase then in the safety, and it's an increase in actually the hauling capacity and the overall effectiveness of these things. It's not just the large equipment. If you can automate the haul trucks, you can automate anything. So I just thought I'd show you a few slides. These are examples of the sort of mobile equipment that I'm talking about when I'm talking about what a mobile equipment is. Now, what's interesting from my perspective as a trainer is most of these machines have a fair bit of hydraulics on them. So, hydraulics is very much part of industry. So this is a loader that's often used in civil construction and mining, and of course, just a general purpose digger there. An agricultural tractor. So this one here, this has been set up for use with a civic council. This is a lawnmower attachment on the front of the tractor. So this is, a very high-tech piece of equipment, of course. And again, very hydraulic and very capable and very ready to be used in Industry 4. If you think of a tractor, you often think, okay, these things, you have a steering wheel and a few levers to move things. Tractors have changed, and they've changed as much as cars have changed in the last 20 or 25 years. You get in a car now, very often you're going to have a digital dashboard. Very often you're not going to have a gear stick anymore. That's automatic. And very often you're going to have things that have, for example, GPS location. And again, even if you don't have a self-driving car, you certainly may have a car that has adaptive cruise control and can come down to a stop if it sees a person on the road. So all of these technologies that are developed for the automotive market are certainly moving away from just being employed in the cars and moving into trucks, moving into tractors, and moving into, of course, large equipment. So the interaction with these is done via digital screen, touch screens, and also these tractors are getting connected to the web with much more commonality. And in fact, I found a photo here. This is a driverless tractor. You have to admit it looks pretty cool. I mean, how many tractors do you see that have the red rims on them? So this is the way things are going. If the advantages that can be seen in the haul trucks can be taken into an agricultural context, then those advantages that are gained in that market will be brought into the agricultural context as well. So in a lot of cases, these machines are running on a CanBus. So a CanBus is a digital communication protocol, and it's a communication area network. And essentially, it's a digital protocol. Zeros and ones fly around. All of the controllers and the actuators basically communicating with each other via digital communication. So this is just a look here at what the protocol is and how it works. I'm not going to go into that. That's really not what this is about. But with CanBus, it is very, very digital already, and that makes it very easy to integrate then with further technology and sending data off board. So here's an example here. This is some agricultural equipment, and this is the sort of equipment that is sending this information that you can see on the screen in real time, and this could be analyzed anywhere in the country. So it was certainly, with regards to analytics of how the machine's running and how the effectiveness of that machine in that farming operation. Certainly these are things that you can tap into and learn about and optimize the operation of that thing. So agricultural data is absolutely useful to us. Okay, it's not a factory of the future. It's not a factory at all, but it doesn't mean it can't be connected. Okay, so that's an example there of what can be done. The connectivity of this equipment is a pretty simple thing to do. So I just thought I'd highlight one of the products that we have. So this is called a Connect Wave. So the Connect Wave basically is a CanBus enabled device, and it simply listens to the CanBus and it will send the selected data that you tell it to wherever. So it does it over its own little wireless network, or it can talk via GSM or a Wi-Fi to the web. So it's used to gather data and send data away for analysis. A modern control system can easily be adapted into one of them. Without going into a specific application, and I'm being very aware that some of the stuff that we are doing here, I don't want to talk about that specifically. But in general terms, a lot of these equipment will have a control system. The control system will be overseeing the valving, the actuators, the pumps, and it's going to be commanding the system essentially. And also talking to the engine management via a CAN J1939 signal. So these are modern controllers, and essentially they're programmed. They will talk via CanBus to a HMI, a human machine interface. So the HMI becomes, in very many cases, the dashboard, and this is going to bring real data about what that vehicle is doing at any time, essentially the same as a digital dashboard on a car. That then can also have an interaction between another piece of equipment. Say, for example, if we have an application that requires a wireless controller, so somebody can walk around that truck and operate the truck without having to be inside it, then the Wi-Fi and everything can also talk to CanBus, and that will also be displayed on the HMI. So we can have a look at things such as weight scales for equipment for construction. Live data of weight of what it's carrying can be read, displayed, and data is stored. And then the Connect Wave can enable that information to be sent to the cloud. And once it's in the cloud, of course, it can be accessed anywhere. And the information can be basically tailored to people who want to use it. And that way they're seeing what's important to them, and other people are seeing what's important to them, and they're not necessarily seeing things that aren't important to them. These are technologies that we're employing right now with great success. I just thought I'd highlight this. This is one of the nicest things that I've seen. So this is a little camera, and this has been deployed on this truck in various locations. So this is a camera that's actually an Australian product as well. Now, so this camera is then on the truck, and it could be used for safety. So, for example, this is a reversing camera. So in the same way that you're going to put this on a car, you can put this on something like a construction vehicle. So that can look forward as a dash cam as well. And that way you can get data of what's actually happened. If there's been a vehicle incident or something like that, you can tell if it was driver error, or you can certainly find out who was to blame if it wasn't the driver. So information like that can be sent remotely as well. So this is one of the nicest things that I've seen. This is quite amazing, actually. So what we've done in this case is we've taken a drone image of the top of the truck. Now, this truck had, I believe, 6 cameras around the perimeter of it. And so looking forward, backwards, and sideways. And then this software actually was able to stitch that together as a top-down image in real time. So we've seen these technologies certainly on high-class luxury cars, where you can do the top-down view. You can certainly use it in an industrial context. And the big advantage with this is that you can actually see anyone who's walking around that truck, and you can bring, there's clear evidence actually, not only you can bring, but people have been demonstrating that they can bring their safety incidents around person to vehicle incidents on a construction site and so on. They can bring those incidents down to a functional 0 where there's 0 injuries. So the driver's much more aware of everything that's happening around them. Okay, so again, very different from a factory, an automated factory, the factory of the future, but certainly high tech, and certainly new and certainly very innovative. Further to that then, with fleet maintenance, you can grab a piece of equipment, and again, we have the HMI and the controller. That then can send information to a CanBus. It will be sending information via CanBus, and we can access that with certain tools for servers. So service technicians can then get access to everything that's happening to help troubleshoot the system. So a modern car, of course, you can take this into a workshop and they can just hook it up to a computer, and the computers will do the analytics and tell the serviceman what's wrong with the car. That's exactly what happens with these machines as well. From a service perspective, the same data can then be used for optimization, analysis of what the machine's doing, how it's working, and optimizing the tasks, and also looking at the predictive maintenance and doing the maintenance planning as well. So all of the information that this thing is now doing, it's now being turned into data, and that data can be accessed anywhere for any function. And of course, it can be sent to the cloud as well for remote access and remote analytics. So certainly, if you can imagine it, of that data being of interest to you, it most likely is, and it can be done now, and it is being done now. If you can then have a look at some mobile assets and look at getting that information into the cloud and doing information analytics with it. Certainly it doesn't just have to be a piece of mobile equipment. It can be anything at all. So a fleet of devices. So for example, we've got some applications where we're employing exactly the same technologies in use with building services. So, for example, it's not just about the machine. It's not just about an articulated machine. Certainly, it's about connectivity. So the connectivity is that, well, I want to know about what that thing is doing, how's it functioning, and if we can collect information on that, we can look at how to optimize that and develop more efficient products and have more efficient maintenance schedules there. So certainly it's about connectivity, and the asset doesn't have to be any industrial equipment. It can be domestic as well. It's still the same connectivity. Managed IoT solutions, that's the Internet of Things. So essentially we can get information from a number of sensors, analyze it remotely, collect information on that, and there's many options available to us and the wider market, of course. Connectivity is really the Industry 4. In the Australian experience, it's about connectivity. Okay, it's about the data and the connectivity. So the data analytics, basically, I've read an article recently. This individual was saying that, well, in the 20th century, the most important resource was oil. It defined the 20th century, and the most important resource for the 21st century is data. Okay, big words. I would still suggest oil's still pretty important. We still need machines, and they're still going to need to be lubricated. But certainly data is the thing that everyone's interested in. That's a bit of a catch cry at the moment. So if you don't have sensors on your thing, then you're not going to get any data. If you don't have the connectivity, you're not going to have any useful data. So the data analytics, there's really 4 levels to what you can do with the data. Just as a few final points. So a descriptive analytics is the analytics of what that machine or unit is doing now. Okay, tell me what you're doing. I want to see live data. That's descriptive analytics. A level above that is the predictive analytics. So this is, again, what we talked about in our last session. The predictive analytics is, okay, we know that what the trend has been in the past, we know what the current condition is now, and we want to have a look at projecting that into the future. So finding out really about the optimizing of planned shutdowns and so on of that equipment. So that's a level above descriptive analytics. Above that is prescriptive analytics. So this is then prescriptive maintenance. Or prescriptive analytics is, of course, when we're looking at not only what we think this thing will be doing, it's analyzing itself what it can do. So it's going to prescribe a course of action and say, look, I would suggest that you should do this to me as a machine. This would help me be optimized. So that's a level above predictive. Now, the 4th level, I would argue we're probably not there yet, but certainly we're moving in that direction, the cognitive analytics. And this is the machine that's thinking for itself. The machine that's not only doing that, but also learning from its experiences. So you can see how the data is going to be absolutely vital if you want to progress like this. And it's the connectivity that enables this analytics, and it's the analytics that are going to change what we're able to do with equipment in the 21st century. Okay. Yeah, as I said, that's really what I wanted to cover today. Without going into any specifics of what we're doing, I don't want to really give away anything that we're doing specifically. I trust this has been worthwhile. It's certainly an interesting subject. It's one I enjoy presenting on. So again, I would just like to point out that you can register for our upcoming webinars. We have webinars on all sorts of topics, cooling technologies, and we're doing accumulation and many other things. So I myself will be presenting a few more topics in the near future. Certainly you can go to our website and you can register there, but follow us on your preferred social media. Okay, thanks for joining us today, and we'll see you down the track.